All right, so last night at the speakers' dinner, Jose gave a final plea to the speakers, said, please, go back, review your materials, review your slides, make sure there's nothing in there that a CEO or grandmother would find objectionable. So I thought the easiest way to do that would be just to delete my slide deck. So I don't have any slides today. I'm going to try to tempt the demo gods and just do a demo the whole time. But I assure you, no CEOs or grandmothers were horrified during production of this demo. So I'm going to tell a story, and I'm going to use Stackhammer, which is Cloudsmith's hosted product, or offering, and the Jenkins module and a Jenkins server as the backdrop for the story. So my name's Ken Hussey. I'm with Cloudsmith. You may have heard a talk by Henrik Lindberg earlier today about Geppetto, which is our free open source IDE for Puppet. So the story involves Cloudsmith and New Relic. Anybody familiar with New Relic? They have some really good performance and server monitoring tools. Chris Kelly's giving a talk tomorrow. He's from New Relic. You may have seen him downstairs in the exhibitors area. He's doing a talk tomorrow at 2 o'clock. Recommend you check it out. We've been working closely with New Relic over the past few years, and recently they came to us and said, we've got this Puppet stack, a bunch of Puppet code that we kind of been, we've had some resources, some organizational churn, and the guy that came to us said, I kind of inherited this code, and I want some help. I haven't had a chance to look through all the code, but where can I find good examples of Puppet code? So we said, oh, well, the Forge has lots of great examples of Puppet code. So we recommend you, check out the Forge, download some modules and see what's there. So Stackhammer is fully integrated with the Forge. So I'll use Stackhammer as a way of explaining some of the things we told New Relic and helped them with their stack. So there's lots of useful modules in the stack, and a lot of them represent best practices in how to write Puppet code. One of the modules I've been using and working with a lot recently is the Jenkins module by our Tyler Croy, who happens to be giving a talk at this very moment in another room. So I'm going to add that module here to my stack. So in Stackhammer, we work with complete Puppet configurations. Rather than working on just individual modules one at a time, we work on entire configurations that involve a bunch of modules put together. So I'm going to import the Jenkins module from the Forge into my stack. And I chose to import it with all dependencies, so I noticed that it's using standard lib, which is a very useful set of functions provided by Puppet Labs. Happens to run an APT module too, which doesn't really apply because I'm going to be using Amazon EC2 and Amazon Linux for my target. But it brought in the Jenkins module. So New Relic went off and took a look at some of the code and the standard lib, and he said, that's great. But we have the stack that we inherited, and how do I know if the code's any good? And what we said, well, there's some tools out there to help you do that. Geppetto is an open source IDE you can use to find problems in your code. And you may have heard of Puppet Lint, thanks to Tim Sharp at GitHub, as another tool that's quite popular for finding lint in your code. So Stackhammer has built-in support for doing Geppetto and lint validation. So you may have noticed when I added the Jenkins module to my stack, I instantly got a list of errors and warnings in the code based on Geppetto and lint validation that it ran as it brought in the code. So they went off and used this to take a look at their stack. They found lots of errors and warnings. Really happy to find things, some common patterns like autoloader support. Make sure your modules are loaded automatically by the autoloader to name your classes the right way. And they used that information to help fix some of the obvious problems in their stack. So I'm going to go ahead and fix some of the obvious problems in the Jenkins module here. Not uncommon for some of the modules in the Forge to have errors that have gone undetected, unfortunately. So I'll just quickly fix these problems. There's this guy here. So this just tells Geppetto validation to ignore that variable that it doesn't know about. So kind of fix the main errors, and I could spend more time going through all the various warnings in here, but I won't dwell on that. Another way to get a sense for how good your code is, or to understand it better, is to look at a dependency graph of the code. So go ahead and do a dependency graph view of the code. And I can see that all the dependencies seem to be resolved fine. I can see how the modules in the stack are connected. And so they're happy with that, but they said, you know, there's got to be a way of testing, you know, okay, so syntax and semantics, it's good to know that that's good, but there's got to be a way of actually, you know, testing the code before we deploy it to production. We said, yeah, there's some tools out there. RSpec-Puppet is quite a recent one, gaining quite a bit of popularity. Anybody familiar with RSpec-Puppet? Handful. And it's used primarily for kind of unit level testing of modules. And it turns out that a lot of the modules in the Forge actually have RSpec tests in them. So if we take a closer look at this Jenkins module, switch over to the file view, we can see that there's a spec folder, which is by convention where you put your RSpec tests, and there's some helpers here, and there's a couple of actual test files, spec test files containing a number of tests. So wouldn't it be great if we could, when we take all the modules from the Forge and put them together into a stack, wouldn't it be great if we could run those tests very easily? So we said, well, yeah, actually Stackhammer can do that. So if we add a simple test here that automatically provides me with a list of break files in the modules that I brought in, I can run the rake file that happens to be part of the Jenkins module, and I want it to collect output. So I'll give it the output location, which is modules Jenkins. So I just told Stackhammer about that test, and now I want to run that test. So I'm going to go ahead and tell Stackhammer to run it. So again, RSpec-Puppet is free and available for use, courtesy of Tim Sharp. And so what's happening behind the scenes here is we're committing all these changes to a repository at GitHub. We're spinning up an Amazon EC2 machine to run Puppet, a specific version of Puppet. And the way RSpec-Puppet works is it actually produces a catalog based on your code, and then when you write your RSpec tests, you write questions or conditions, or you describe the characteristics that you expect that catalog to have. So it should contain this class, it should contain this resource, that kind of thing. So we can see that the unit tests that that were authored by the Jenkins module author all passed, and we can expand the list of tests that were run, and kind of makes us happy. So now that I seem to have brought the module in, I should be pretty close to being able to deploy a Jenkins server based on this module. But before I finish doing that, I want to add a couple of plugins by default that I like to use when I use Jenkins. So I'm going to create my own module for that. I'll call it the plugins module. So Stackhammer creates me all the scaffolding I need to work with a module, and I can add a dependency, since this is going to depend on code in the Jenkins module. The screen size is starting to... So I can add a dependency. And then I'll want to modify the default init manifest to include some information about which plugins I want to include. So I've authored that ahead of time. I'll go ahead and do that. So when I install my Jenkins server, I want to make sure that the Git package is installed. I want to install the Git plugin for Jenkins. I want to install the GitHub API plugin for Jenkins, which happens to be required by the GitHub plugin, which is something I really want. And then I'm going to install a Stackhammer plugin. So we go ahead and do that. Now, before the demo, I went and created an empty machine, deployed it to Amazon EC2. So it's sitting there with Ruby installed on it, Puppet installed on it, and it's ready to go. But of course, in order to put anything interesting on it, I have to apply some classes to it. So Stackhammer does role-based deployment. So all I need to do is define a role. I define this role as the Jenkins server role, and I'm going to add some classes to it. In this case, I'm going to add my Jenkins class, which is what I need to install a Jenkins server. And I'm going to add my new plugins class, which is what I need to install the plugins that I want in my server. And now I'm essentially ready to go ahead and deploy. But you wouldn't necessarily always want to go and write a bunch of stuff and just deploy it to production, and maybe watch syslogs or something to see what happened. You want a bit of a safety net. So we talked to the New Relic guys, and they said, it would be great if we had a way to test it even more. I mean, so the RSpec tests are running, the syntax semantics looks good, but is there another safeguard? And we said, well, actually, have you ever used the no-op mode Puppet? So you can actually tell Puppet to produce a catalog, but stop short of actually making any changes to the system. So in Stackhammer, we call that dry run deployment. So we can actually deploy this stack with our Jenkins server and the plugins we want installed, but stop short of actually materializing that on the machine, but just give us back the catalog. So I'll go ahead and do that. And gives me the option to deploy in dry run mode. So the way Stackhammer works as a tool is everything, all the Puppet code you write, all your configurations are stored in a Git repository at GitHub. And when I want to deploy something, it will spin up an Amazon EC2 machine. It will clone the repository over on the machine, and it will tell Puppet to do what it needs to do to apply all the manifests. So it's done. And I can see that it worked by looking at a visual representation of the catalog. So this is a graph of the Puppet catalog, the resource graph that it produces internally to decide what it needs to do. So you can, if you looked closely, you can see all of the various resources. This is a relatively small catalog. As you heard, if you were in Nick's talk just a moment ago, these things can be pretty big. So this is an unrealistically small one, but it is a complete Jenkins server catalog. So that's cool. But then, they talking more to the New Relic guys, and they said, well, we have this existing stack, and it's take us forever to go and write brand new RSpec tests for all the code, because that kind of requires that we understand the code. So we'd have to take all the time needed to understand the code, and then spend all this time writing RSpec tests. And RSpec tests are typically self-serving, right? They're great during development, and they help you, prove your logic. And if you do test-driven development, it's great. But if you're in a situation like us and we get an existing stack, we need a way to test the stack we've got. And we're afraid of breaking anything. We don't want to change anything and break something by mistake. If it ain't broke, don't fix it. So what can you do for us? So that led us kind of to an epiphany. And that's kind of the main, punchline of my talk, which is the ability to do regression testing or fact-driven testing. So I just dry run deployed a machine based on the code I have now, and if I consider that a good known state, I just took a look at the catalog, it looks good to me, I can consider that a baseline, and I can generate myself an RSpec test based on the contents of that catalog. And what that helps me do is now I have another safety net to help me go and hack away at my code, make changes, and if I want to rerun my RSpec tests, I can double check that the catalog ends up being the same, or that it doesn't become that materially different. Or if it does, I can look at those changes and decide, are those good changes? Is that really what I wanted to have happen, or did something go missing that shouldn't have? So I just generated an RSpec test for that deployment. If I switch over to my file view here, I can see that added a couple things to my stack. It's added the facts on that Amazon EC2 machine that were used when that catalog was produced. And it's also generated an RSpec test for me, a host RSpec test that tests that the catalog contains everything it did when I did that deployment. And it's also generated a test description for Stackhammer to actually run that test. I can take a look at that, and I can see that it has the name, it has a rake file that it's created for me. It references the facts that were captured and put on the file system, and it tells Stackhammer to look for the output in the right location. So now I can run all my tests again. This time it's going to, I'll have to commit my changes first because everything's done through Git and GitHub. This time it's going to go and use a test harness machine that it has running on Amazon EC2. It's going to get the latest bits from that repository at GitHub, and it's going to use RSpec-Puppet to run all the tests. So I'm going to run both my Jenkins tests and my demo tests, and take a little longer because there's more tests to run this time. And while we're waiting for that to finish, I can show, oh, I just finished. So if I take a look over at my testing tab again, I can see that, okay, there were 31 tests that it ran to test the contents of the catalog. They all passed, and of course the Jenkins test passed again. So I'm pretty confident now about this stack. So I'll consider that a baseline. I generated myself a baseline test. I'm going to merge that content to source, and what that does in Stackhammer is it says, everything I do in Stackhammer happens in my own sandbox branch, so it's isolated from everybody else. So every other user who might be working on the same GitHub repository actually can work on their own branch, their own sandbox. But when I merge to source, it merges it all back to the shared branch, which in this case is master. So now I want to, I'm a Puppet guy. I like to tinker a little, and I want to take a closer look into what I actually was using when I used this Jenkins module. Spent some time looking at it recently, and I noticed that there's I've been using various versions of it, and there's a plugin manifest which goes and sets up the directories that are needed to put the plugins into and make sure that there's the right group and user definitions. And then there's an exec that's used to actually install the plugins. But recently this manifest plugin install manifest showed up, and turns out it does essentially the same thing. So I thought, well, that's kind of weird. That feels unclean for there to be that much duplication here. So I'm going to go and, I got a nice baseline, so I'm going to play around with it and see if I can improve it. So I'm going to simplify the plugin manifest. So instead of being a definition, I'm going to change it to a class, because maybe I want to reuse the parent dir and the dir of my Jenkins plugin in other places, and this is the one place where I need to define my group and my user, so I'll go ahead and do that. And now my install manifest, I want to make changes to that so it uses the stuff that's in my plugin manifest. So I'll do that. So this guy's going to include my plugin manifest, my plugin class, and because the directories and group and user are taken care of for me, there's all I need to focus on in this manifest is actually doing the exec to install the plugin. So I'll go ahead and make those changes, and I'll validate everything to make sure that it's all good. And the next thing I'll want to do is, something seems to be hung up. Tempting the demo gods. Take a look at the content of these guys. So our plugin looks good. And install looks good. All right. Let's see, cancel that. now I want to deploy, now I want to rerun all my RSpec tests. So I made a change. I tweaked some of the code, and I want to make sure that I haven't broken anything by doing that. And I seem to have broken my, I think the internet is causing me trouble. So now is where we revert back to the video that I did. It's not behaving, so luckily I have a video backup. Might all look familiar to you. Okay, so this is the point where I want to run. Network can't be trusted. So I want to run my tests again. I commit my changes to my Git repository, and it goes ahead, commits them to GitHub, and then it goes and reruns all those tests. And in order to tell me whether I've broken anything with those changes. So it takes a little bit longer this time because there are going to be failures. So while that's running, I'll explain. Actually, I can fast forward. The beauties of video demos. Okay. Well, that was before when I created my baseline. All right. So here's where I made my changes. Okay, so this time when I run, there are failures. And I see that the Jenkins test, there was a test to make sure that the parent folder for the plugins was created. So there should have been a resource for that in the catalog. And turns out that my catalog test, of course, checked for that as well. But interestingly, the catalog test also found something that my unit test didn't. It found that the group for the user that was created wasn't set correctly. So inevitably, there are things that are going to be in your catalog that you don't anticipate when you're writing your Puppet code. So generating tests automatically from known good catalogs is one way to really catch the complete view of everything that should be there. So I add some code to my plugin manifest to make sure that the group ID is set. And then I make sure that the parent directory is managed in addition to the directory where the plugins are going. And then I save that change. And now I can go back and I can run all of the tests again. This time they should succeed. Fast forward for that. So this time they succeed because, once again, the catalog contains everything it should. And I'm in a happy state again. I'm going to do another dry run deployment just to make sure that the catalog still contains, for sure, maybe I don't trust the tests. I go and take a look, and another interesting thing I can do with StackHammer is I can compare two different catalogs. So I have two different dry runs. I'm going to compare the state of the new dry run, the catalog from the new dry run, with the one I did previously. And the test told me that it contained everything it did before, which sure enough it does, but it actually contains something new. So I want to take a look and see what that is. And of course, we've changed a define into a class, so it makes sense that the catalog contains a new class. But otherwise, all the other resources are there as they should have been. So now I'm going to go and merge these changes to source. It's another good baseline I'm happy with. So natural thing I want to do now is to do this continuously. So I've been working in my own little sandbox, running tests, doing dry run deployments. But wouldn't it be great if we could catch regressions like this on a continuous basis? So for that, we have a Jenkins plugin. And with the Jenkins plugin, which is automatically triggered by a commit hook. So when I just merge to source, my job runs, and I'll see that it will actually go and do all of those steps to check all of the Puppet code on the master branch that would be shared with my other team members potentially, so that we can do this. And depending on the process and workflow we have at our organization and how we collaborate on this and treating our infrastructure as code, we can set this up to automatically run these kinds of tests. The validation test to check your syntax and your semantics. We can run the RSpec test to check both unit level tests on the modules, but also tests for entire configurations that are based on facts from real machines and based on baselines from machines that were at a known good state. And incidentally, the plugin also has support for viewing the catalog, viewing the dependency graph for your stack, and also the catalog graph. So every time you run your Jenkins job, you get all the same results that you do by interacting with the UI from the Jenkins plugin. So if you don't want to interact with the UI all the time, you set up your Jenkins job, it's done, it's ready to go, and it just runs, and it helps you monitor your changes in your Puppet code. And that is essentially everything I wanted to cover. So I'd be happy to answer any questions. Dan?
I have a whole queue of questions.
Whole queue? Okay.
I was actually curious, you talked about running no-op early on. I was wondering, since you're just spinning up throwaway instances in EC2, why bother?
I'm sorry, what?
Why bother running no-op since you're just spinning up throwaway instances in EC2?
Because sometimes it's hard to undo mistakes that you make in your Puppet code. And so the no-op, what it does is it lets Puppet produce the catalog in the environment where it's intended to be, but without actually making the changes. So I can very quickly and iteratively make changes to my code, see a catalog graph, make changes, see a catalog graph, without actually installing it on the machine. Otherwise, what I would have to do is spin it down and spin up a new instance. And every time I spin up a new instance, of course, it takes that much more time.
Have you guys thought about like a Travis CI style plugin and I'm used to that?
We have considered it. We chose Jenkins, for better or worse.
Travis CI style stuff to do like regression and something that like sends you emails of differences for private GitHub repos would be really awesome.
So we can do that with the Jenkins plugin very easily. Yeah, we have the technology. Yeah, we chose Jenkins. Yeah, we're happy with it. There was a good, or Tyler put a good Jenkins module in the Forge, and we've been playing a lot with it, so it just made a lot of sense. Yes?
So we run everything in hardware because we have to, and I like a lot of sort of the interface and a lot of the presentation. So is there a way I can port some of these things using either standard Puppet tools or something else to dealing with my own infrastructure that I've got on a data
Yeah. So a lot of that, I mean, what you saw here, there was nothing really rocket science about it. What it was taking a lot of existing tools and technologies and tying them all together. So the Forge is there with lots of good modules that you can reuse and see good examples of code. Puppet Lint and Geppetto are out there and free, and they can be used to validate your code. RSpec-Puppet is out there and it's free, and it can be used to run your RSpec test. The only thing we did that's a little different with RSpec to kind of take it to the next level, and we think something that's really promising around RSpec, is integration level testing. So we patch RSpec to inject facts. So I didn't show the content of my RSpec test, but what it does at the beginning of the test is it says let facts be empty, and then we patch RSpec to when it runs the test, it takes the facts that I've extracted in YAML or JSON formatted, and it injects them so that I'm using real facts from the machine when I'm running RSpec. But otherwise, like, all of this technology is out there in various forms, and we just tied it all together into a workflow.
Okay. Cool.
Yeah. So the take-home, really, I wanted to reinforce the take-home is that I think there's a lot of promise in doing various kinds of testing of your Puppet code. We've been really excited about some of the things we've been able to do with our RSpec-Puppet in a short amount of time, and we think everybody could benefit from doing more of it. Question?
Yeah, what about testing custom facts or custom types of providers?
So this all uses the normal Puppet mechanisms. So when we use Stackhammer to deploy a machine with Puppet and produce a catalog, it would make use of custom facts when it generates the facts, because it's doing that on an Amazon EC2 machine. So there should be no problem in doing that. It takes all the modules that you've written. If you've added custom facts and types and providers in there, it would all be included in what's processed here. Any other questions? Anybody thirsty yet? Another 25 minutes to go before the taps open. Yes.
What about Puppet Labs Spec-Helper and the adjustments to spec testing that that makes?
Yeah, so there's a lot of really good, that's a good point. If you're going to look into RSpec, there's a spec helper from Puppet Labs, which is really useful and does a lot of the boilerplate type of stuff that you need to do with RSpec. Our tool uses the spec helper when it generates the rake files and generates the scaffolding for the unit for the RSpec test that we run. And recommend, there's a lot of good patterns emerging around RSpec.
If you don't use it, leave symlinks laying around that can...
Yeah, symlinks are a real drag. Yeah, for sure. So thanks everybody for your attention. If you found it interesting, and the Cloudsmith guys will be around the rest of the conference. You guys want to chat about anything we've done? All right,